In this video, we're going to talk about 5 specific ways your code could be costing you way more money than it needs to. We're going to dispel some common misconceptions with Claude models specifically. We're going to see what they look like in code. And finally, we're going to wrap up with a solution you can implement today so that this fixes the problem, make sure it stays fixed. Let's get into it. So the very first thing I want to talk about is you might not realize it, but it can get very expensive being slow to upgrade to the latest models. And Anthropic's Haiku 4.5 is a brilliant example of that. It's their fastest, least expensive model on the market. But the best part is it performs as well, if not better than Sonnet 4 at 1/3 the price. So most often we see people using older models that still cost a lot, but they're not necessarily as good. And often you'll put out a product, for example, and not touch that code for 6 months, a year. And the models have advanced significantly. Often it's one line of code, just changing the model call, and you have an opportunity to save a substantial amount, right? So the real barrier here is psychological, not really technical, right? Where you think that if you change something, it might break, or because this says Haiku and not Sonnet, it's not quite as good, but it will work. And you have a real opportunity to save a significant amount of money on your daily operations. Similar to this, something to consider in the same sort of vein is making sure to use the right tool for the right task, right? So while Opus 4.6 is Anthropic's most capable model, it would absolutely be overkill for simple tool calls, right? Alternatively, if you've got something set up with Opus 4.5 or Opus 4.1, Sonnet 4.6 recently came out and it offers similar performance to the previous iteration of Opus at 1/5 the price. So this can get out of hand really quickly just by using the wrong LLM for the task. So we've optimized our LLM. We've found the correct tool for the task. The next thing we really want to do is make sure that we're optimizing the computing power. So the best place to start would be at input tokens. So I know that I am definitely guilty of this, and a lot of other people are as well, where we write our system prompts as though we're speaking to another human. But that tends to be really verbose, and there's a lot that AI doesn't need from that. So you're billed for every token in your system prompt. So every extra word is just wasted usage, right? There's a great example here. Bear with me. Please carefully analyze the sentiment expressed in the following text and provide a classification, whether it is positive, negative, or neutral, which is a clear and understandable sentence, but all AI needs is sentiment classification, positive, negative, or neutral. That is significantly less tokens and significantly less spend. It also works out to being a much better result because there's no wasted wording. AI just gets straight to the heart of what it needs to do, and you save a bunch of money. Anyway, there are a lot of tools you can download to implement this. A great one is LLM Lingua that's put out by Microsoft. What it does is it just optimizes for minimal performance loss while getting rid of all of the unnecessary tokens. So you can download this guy, or you can just go to good old Claude.ai and have it optimize your system prompt for efficiency. Keeping on the topic of input token optimization, something that is an absolute must for large static blocks of text is making sure that your system prompts are structured for caching. If you're not aware, caching is essentially sending the static blocks of system prompts or whatever to the agent, and it just hangs on to that for future calls. Okay, so this is fantastic because you can see a lot of system prompts have the same message, base message, documentation, context that prepends every message. So if an agent can hang on to that, it on average costs about 90% less in tokens than it would if you sent the entire text, right? So anything like you're a specialized customer service assistant with the following guidelines, right? And then your guidelines would include documentation and anything the agent needs to complete the task appropriately. That agent can hang on to that and save you a bunch of money. So if you're not doing that already, that is the biggest single lever you can pull to optimize your input tokens. But what we see often as well is people have implemented system prompt caching, but it's failing silently for a couple different reasons. Maybe it's the config wasn't appropriately written for whatever model provider, or let's say the system prompt changed and it invalidated the cache. That can be a real silent killer because you're paying 90% more than you thought you would have had to while this is failing in the background. So if you're not already doing the system prompt cache, it's the difference between something being affordable and completely unsustainable. And if you are, you want to make sure that it is actually working appropriately, right? So caching is effective for static blocks of text that the agent can hang on later. And it's probably something you shouldn't worry about if you have consistently changing context or user content, or your system prompt is less than 1,024 tokens, which is cost insignificant as it is. So we've talked a lot about optimizing for cost by updating models, making sure that we're using the correct tool for the task, optimizing input tokens. And if you're wondering if any of these are hiding in your own code base, that's exactly what Frugal does. If you want to find out and get to the bottom of it, you can book a free demo at frugal.co/book a demo. I'll leave the link in the description and you can get to the bottom of your bill. So like I was saying, we've optimized the model, we've optimized our input tokens. Next in line would be output tokens. And the nice thing is that the same principles apply for the output tokens as they do input tokens. Sometimes our models will pretend that they're speaking to a person and they'll give these really long natural language responses as if we're talking over a cup of coffee or something. And like the input tokens we had talked about earlier, every one of those tokens costs money. So if it's not necessary, it's just extra spend. So there are a few techniques people use to get the agent to respond in as little words as possible. And the really good one is using a tool call to force a structured output. Okay, so you can have your agent go and pretend it's speaking to a tool when it calls the API so that it sends as though it's speaking to an LLM or another machine rather than natural language. And that just gets to the heart of what the output actually needs rather than a conversation like it would be for people, right? So as we see in the example, it gets rid of every filler word and just use key value pairs to deliver the message, right? Name, this, description, that, you get the idea. So it delivers a very, very concise, parsable output that's generally 50 to 80% fewer tokens than the freeform conversational response. This is another great way to save on tokens. And lastly, since output tokens are significantly more expensive than input tokens, a stupid, simple solution that you can implement really easily is just putting a hard limit on output tokens for your model. And that is as easy as one variable, max output, 200 tokens, whatever the limit might be for yourself. Very easy way to make sure that you're not going off on unconstrained tangents of natural language responses. All right, quick recap. You want to make sure that you're updating to the latest model. Your prompt is optimized and compressed. It's structured for caching. You're also making sure that you've got structured outputs and a hard token limit on outputs. But even if you implement those 5 fixes today, the problem persists that there's no systematic way to catch these and other cost traps before your code hits production. That's where Frugal comes in. They take a look at your entire code base, and then they do a pull request that offers the proposed optimization and quantified savings for each change. There's no homework or dashboards or anything like that. They just fix the code and it works and your bill goes down. So book a free demo today at frugal.co to see how Frugal can find and fix these cost traps in your actual code base. And make sure to subscribe for more application cost engineering. See you in the next one.